Welcome, students, to solving square root equations algebraically. So we're basically just going to be doing reverse PEMDAS here. We've already done a couple warm-up problems that were like this, so you've seen it before. So I'm going to start with, of course, adding and subtracting anything that is outside the square root. So in this case, I have this plus 2 here that I need to get rid of. So I'm going to do that by subtracting 2. And then, so that's done. Then I want to multiply or divide to cancel anything outside the square root. So when you have a number in front, you have to remember that this is really the number times the square root portion. So to undo a multiplication, you need to divide. It's really tempting sometimes for kids to want to subtract this number away or add it, and that will not get rid of it. So make sure you divide it. So then I have square root of 3x plus 1 equals 10. Now we're on the exponent step. So it's easy to forget sometimes that a square root is really an exponent. A square root, remember, is the same as a 1/2 exponent. So a square root is the same as a 1/2 exponent. So canceling out the square root fits in the exponent step. So to get rid of it, you have to use the reciprocal exponent. And the reciprocal to 1/2 or square root is just a 2. So to cancel the square root, you're going to use a 2. So actually, let me rewrite it down here. So I have square root of that equals 10. So I'm going to square both sides, take it to the second power. The square root and the squared cancel each other out, which just leaves me here with 3x plus 1 equals, and then 10 squared is 100. And then just go ahead and keep doing reverse PEMDAS to get the x alone. So I've got, so if I go back up here, I finished the exponent step, and now I'm inside the parentheses, so I'm back to the beginning. And I want to subtract away that 1. And then, so that's done. Then I'm back to multiply, divide. And can I multiply or divide to get rid of anything? Well, yes, I can get rid of that 3 by dividing it, because that means 3 times x. So then x leaves me with 33. Now, what you always need to do with a square root problem is check your answer. You always have to check your answer because sometimes there's something called an extraneous solution, and I will write that later on here for you. But it's called an extraneous solution, which means when you solve, you could get a number that you think is the answer, but then when you plug that number back into the original equation, it turns out to have been wrong all along. So you've got to check, because that can happen sometimes. So the way you check is to grab your calculator and go to a calculator page. And that has a bunch of stuff on it, so let's start a new one. And you're basically going to type the equation into the calculator, but where you see x, you're going to put the number you just got. I'm going to put 33. So 2 square root of 3 times x, so 3 times, but don't type x, type the number you got for x, which is 33. Then plus 1, and then plus 2, and then equals 22. And when you type it in like that and press enter, it's either going to say true or false. If it says true, then that's the real solution. If it says false, then this is not actually a solution, and you may end up with no solution. So press enter, and it's true. So that means that x equals 33 is the actual solution. So let's try one more together. We're going to try example 2. Okay, so first I want to start with add, subtract. Is there anything outside these parentheses that I could add or subtract? Well, no, there's not. Is there anything else outside these parentheses that I could multiply or divide? Well, no, there's not. And then finally, I have an exponent. Now you may be wondering, Miss P, this is about square roots, and there's no square root here. but really there is. This little guy here, that little 2 in the exponent, he's the square root. So if you wanted, you could write this problem this way. So pull the 2 out to be a square root, and then it looks like a square root, but really that's more complicated, so just leave it like this. So I need to cancel that exponent. So remember, you cancel an exponent with the reciprocal. So let me rewrite. We've got, this is my problem. So I just copied it. Now to get the reciprocal exponent, I just flip my fraction. So I'm going to use a 2/3 exponent on both sides. And that will cancel out both that little square root and the 3, the third power there. So then I have x minus 27 equals, and then 64 to the power of 2/3 is 16. So that's done. And now I'm inside the parentheses, so I just add 27. So x equals 43. And then remember, check it before you decide that that's true or not. So let's check it in the calculator. So type the problem, but replace x with the number you just got. So I have 43 minus 27 to the power of 3/2 equals 64. And remember, when I press enter, if it says true, that's the solution. If it says false, then that's not a solution. But I got true. So that means, yes, x equals 43 is the solution. So go ahead and try example 3 and example 4, and then come back to check. Okay, so for number 3, you should have gotten, well, first of all, remember that a negative sign in front of a grouping symbol like this is really a -1, so don't forget to divide by that -1. It's really, really common to forget to do that and then end up with the wrong thing. So I divided by -1. Then I squared both sides to get rid of the square root, and remember to put parentheses around negative numbers when you square them. And then I subtracted 3 from both sides and ended up with x equals 13. However, when I checked the answer, I got false. It's not actually true. So example 3 ends up being no solution. Here's what that looks like in the calculator. So I typed the original problem, except with 13 for x, and they give me false. That means the negative square root of 13 plus 3 is not actually 4, so that's false. And example 4, it's kind of a long one, but it does come out to something that checks out true. So you want to start off by subtracting 1 from both sides, then divide by 5. Then you're left with the exponent 3/2, so you use the reciprocal 2/3 to cancel it out. That leaves you with 4x plus 17 on the left, and then this right here simplifies to 81. And then subtract 17 from both sides. And finally divide by 4, and you get x equals 16.